In the last video, we looked at outliers and finding anomalies and how to clean data. Once you've cleaned your data and you've got rid of any errors or any anomalies and you know that you have data that you're ready to analyse, then we start to look at things like graphs to see if that can help us present the data in a way that makes it clearer to visualise. So one of the graphs that we're going to look at in this chapter is a box plot. Now, a box plot is the graph that you use when you're thinking along the lines of the medians and the quartiles. And you'll have seen these at GCSE. The general shape of a box plot is like this. This line here, you'll remember, marks the lower quartile. This line marks the upper quartile. This line can be anywhere within the box. And this marks the median. It's never going to be, or rarely going to be, exactly in the middle. It will only be exactly in the middle if all your data is evenly spread out from the median. But normally what you tend to find is that data is bunched up around a certain set of values, be it up this end or down that end. That's when we call our data being skewed. And that's what this box plot shows. It shows some skewness in the data. Now, at GCSE, you learn that you draw these lines, which are called the whiskers, all the way down to the lowest value. But we're going to adapt that slightly now, because sometimes your lowest value, or indeed your highest value, might be an outlier. So if you have outliers, you mark them with crosses. You might have more than one, but any outliers you mark with crosses. Same here. Which means the whiskers go to something slightly different. The whiskers will be drawn to one of two things. Either, if you know it, the lowest value that's not an outlier, or if you don't know what that value is, you'll draw it to your outlier limit. And the same thing happens up here. You'll go either to your highest value that's not an outlier, or if you don't know what that value is, you'll go to your outlier limit. That outlier limit is the thing that you calculate using 1.5 times the interquartile range. Now, let's have a look at example 3. Example 3 takes data from example 1, which was when we were talking about the blood glucose in females. These are the data that we got from example 1. We had the lowest value was 1.7, but we worked out in that example that that was an outlier. So the next lowest value, the one that's not an outlier, was 2.2. We have the quartiles here, and the highest value was 5.1, and that wasn't an outlier. So let's draw a box plot with these data. I'm going to start with the box itself. So Q1 is at 3.2. So we'll come across to here. Notice that I've already drawn the scale down the bottom, and you'll always draw a box plot on a scale. That's our lower quartile. Our median is at 3.8, which is here. And our upper quartile is at 4. So that forms the box. We then draw our whiskers. At the upper end, the highest value that's not an outlier was the actual highest value with 5.1. So we're going to go up to here at the upper end. At the lower end, however, our 1.7, our lowest value, was an outlier. So 1.7 is there. Let's mark that with a cross. The next one, the next lowest that wasn't an outlier, was 2.2. So that's where our lower whisker stops. So we've done the quartiles, we've done our upper value, not an outlier, our lower outlier, and our whisker goes down to the first one at the lower end that was not an outlier. So this is the graph for females. Now, just before part B in this question, we are given some new data about the blood glucose level of 30 males. So same units here, micromoles per litre, and you'll see I've labelled the units on our scale axis here. So this time we know the quartiles, we know the highest value, we know the lowest value, but we don't know yet if there are any outliers. So I'm going to start by drawing the box and then we'll think about the outliers. So our box goes from 3.6, which is there, up to 4.7, and the median in the middle is at 4. Now, before I draw my whiskers, we need to work out if we've got any outliers. We're asked in this question to use the same formula as before. So the outlier limit is at the top end is the upper quartile plus 1.5 times the interquartile range. So for these data, interquartile range is 4.7 minus 3.6, which is 1.1. So 1.5 times that is 1.65. So we're going to go for the upper limit for outliers. That's going to be the upper quartile plus this 1.5 times the IQR, so plus 1.65. So we've got 6.35 there. And for the lower limit, we go from the lower quartile of 3.6 and we subtract 1.5 times the interquartile range, which gives us 1.95. Now, from that then, we need to identify if we've got any outliers. At the top end, our limit goes above the highest value, so 5.2 is where we stop. So I can now confidently draw my whisker here to 5.2 at the upper end. So there's no outliers there. However, at the lower limit, the outlier limit is 1.95, and we know that the lowest value is 1.4, so that's going to be an outlier. Now, because we don't know, like we did here, what the next lowest is, we have to draw our whisker down to this lower limit. So my lower limit of 1.95 is there. And then I'm going to mark my outlier at 1.4, which is there. So we have got the females and the males, the blood sugar level, the blood glucose levels, and we've drawn them on the same diagram like we were asked to. And the reason for drawing them on the same diagram is that it makes it easier to compare what's going on. So in part C, we're asked to make some comparisons here between the glucose levels of females and males. When you're asked to make comparisons, you're going to compare, as a minimum, 2 things. You're going to compare a measure of location, and you're going to compare a measure of spread. That's as a very minimum. So let's think about the measures of location. The easiest one to pick would be the median. We can see that the median blood glucose level for men is higher, for women is lower. So we could say something like males median glucose level is higher than females. That suggests that maybe on average their blood glucose level is higher. But then for a measure of spread, we can see that they also have a greater interquartile range because the width of this box is bigger than the width of that box. So we could say something like the interquartile range for glucose level is smaller in females. Now let's put this in a little bit of context, a little more detail. What that means is we're suggesting that on average, the females have a lower blood glucose level, but also that the measurements of their glucose level are more consistent, and that's what this smaller spread, this smaller interquartile range tells us. So you must make sure when you're answering any question about comparisons that you give, first of all, a measure of location, secondly, a measure of spread, but also you write your answers in context. You can't just say, this one's smaller, this one's bigger. You have to say, the glucose level is smaller, the glucose level has a bigger spread, something like that, because then you're putting it in the context of the question and you're actually interpreting the data rather than just saying, this number's bigger than that one, which doesn't tell us anything. And when we're dealing with data, it's all about the context, as I've said over and over again. So make sure you do these two things and you write your answers in the context of the question. So if you can have a go at exercise 3B now, please.